My name is Ian Evans. I'm a cloud architect at Carpathia, a QTS company. We were just recently acquired by QTS, which is a fairly recent acquisition. So you can see down there, a QTS company. I've been with the company since about February, and one of my primary roles there is really kind of around cloud architecture and bringing that more into kind of a hybrid type of environment for customers. So if they're looking for interconnects or bringing in a private infrastructure, I'll help them with some of those things around compliance and different needs. So as we move through, I'll kind of talk a lot about that. But really the main subject of today is to talk around security and improve application performance and availability within the cloud and also private enclaves. So just a quick little bit about me. I've been in the industry about 17 years. I've worked a lot in network infrastructure planning, a lot of project management, migrations, things like that. Most recently, I've worked at Verizon and also AWS, working in different capacities within their cloud infrastructure groups. And the big goal is really to help customers construct, modify, and operate and maintain geographically dispersed cloud architectures that meet very specific, unique needs. And when I say unique needs, one of our big focuses as a business is to make sure that we address compliance and things like that specifically. Whereas a lot of people will be able to start up an AWS workload or something like that, there may not necessarily be a lot of tutelage on things like back-end security, hybrid security, networking, interconnectivity security, and things like that. So that's kind of where I step in. And like I said, I've held several different roles, and one of the other ones was I've done quite a bit with a lot of the public sector, helped military Sea-Lift Command with a lot of their secure infrastructures, both on the classified and unclassified side for their fleet. So as we look at the digital media landscape, we definitely know there's several things. One is a global audience awareness there. All the workloads definitely span across the globe, so there's a big need for intercontinental connectivity, a lot of geographically dispersed redundancy and things like that. We also understand that anywhere, anytime, access is very important, not only just for specific interfaces on desktops and things like that, but also mobile devices and so forth. And then also understanding the environment of usage peaks. Like I said, we specialize a lot in very, very complex burstable type of infrastructure, and then bringing that into the cloud, whether it's an AWS Direct Connect or a backend connection through like a broadband bonding type solution or something like that. And then also complex, like I mentioned before, complex regulatory compliance. So that includes HIPAA, PCI DSS, anything that has to go around like credit card industry, very specific hardened type of environments where they want complete service chain type of solutions, all the way down from bottom end storage. We may look at things like SED, so self-encrypting drives all the way up through the entire service chain to the top, and ensuring that they have encryption or security through those workloads as it traverses different parts of the infrastructure. And then the need for consistent uptimes and fast speeds around the clock is obviously going to be one of the other very important things. So as we look at the current ecosystem, and we look at a lot of the different events that have been occurring, the sophistication of hacks has been becoming much more prevalent, and kind of a fast-moving thing, and being able to properly track those and pin those down has been a relatively difficult process. So as you can see here in this diagram, there's a lot of things that kind of that will depend on that. Like I mentioned, all the way from storage, compute, network, different architectural pieces, to try to kind of secure that complete service chain and bring it all into one secure environment. As you guys probably know, there's a lot of impacts around security and compliance regulations. Some are very specific, like PCI DSS. They've got a very strict hardened type of guideline that you would follow to be able to secure resources. Other ones are a little less loosely coupled, like HIPAA. HIPAA doesn't, as an example, doesn't necessarily say you have to do this on a router or a switch or your storage, but it allows the organization really to kind of develop and mold that infrastructure in to meet a specific compliance guideline. So there's a lot of unknowns in that area, and people are looking for experts to come in and really kind of help kind of mold and determine what type of infrastructure improvements or changes they need to make to meet that compliance guideline. The cost of non-compliance, some fairly obvious ones, financial harm, lawsuits, FTC investigations, loss of consumer trust, and one of the biggest ones in the industry, it's fast moving, is reputation diminishment. Financial losses for the most serious US data breaches have exceeded over $1 billion in industry. So it's one of those things that's, like I said, it's very fast moving. And we look at it as security plus compliance plus performance and availability. A lot of times when infrastructures are rapidly changed to meet security breaches and things like that, or vulnerabilities, there can be negative impacts on the infrastructure. So really kind of the balancing act is to determine how you can make these infrastructure changes without specifically impacting performance of applications, your network stack and so forth. So what we see in this is the change in the ecosystem and the way customers are actually utilizing cloud. One of the big themes, and it has been for the last year or two, has really been kind of the rise and push of the hybrid cloud. Because customers are really in that type of mindset where they may have very specific types of workloads within their private environments that need to be hardened and restricted. They don't necessarily want it out in the public cloud for a variety of different reasons. Maybe there's performance concerns where they don't want a multi-tenant type of infrastructure and they don't necessarily see consistent performance across multi-tenant shared hypervisors, or they have something that specifically needs to be protected. US government is a great example where they'd have a very compliant type of workload that they wouldn't want going across control planes that are viewable to another company. So you see a lot of that still there, but that doesn't mean they don't want to burst and things like that into public cloud. So with the hybrid cloud piece of it, we see that as a need for the company to be able to not only burst, but also leverage things like geographically dispersed replication of resources, be able to have a solid DR plan that they can fall back on and things like that. So a few benefits of the hybrid cloud immediately are maximize asset utilization. It allows applications in the environment to run in the environment that makes sense for most based on price, availability, and security requirements, as I mentioned before. It allows people to split workloads between cloud and on-premise managed infrastructure. Cost efficiency is a huge one. A lot of the cloud services, while some of them do seem very cheap at first, once that scales in and it becomes a larger infrastructure footprint with a lot of public clouds, it can become cost prohibitive for some companies. So it's kind of hard to model a lot of that cost. So another reason why people like that hybrid cloud is they can kind of pull it back or they can push it in if they see specific types of cost constraints or benefits. And then the higher availability and resiliency, as I mentioned before, leverage geographic dispersed type resources and replicate those across multiple different co-located data centers. And then the increased security piece, which maintains in-house storage for sensitive workloads related to customer data. As I mentioned, some customers are very specific about securing those workloads and making sure that those workloads do not leave that data center prem. So as we look at implementing more of a secure cloud hybrid infrastructure, kind of the way that we've started to frame some of this is because a lot of the technologies, whether it's Docker or it's a converged type hypervisor infrastructure or it's standalone bare metal type infrastructure, there's a lot of different moving pieces, a lot of times a lot of different vendor components that come into play. So as we look at it from a security standpoint, obviously managing each one of those vendor footprints and making sure that they're secure can be a relatively difficult task that may require a lot of third-party resources or a lot of additional staff to do that. And what we're starting to see in the industry here, and this just kind of shows a high level, is between the storage, compute, and the network and all the network specific resources that connect all of these clouds together, we're starting to see kind of the rise of the CMP, the cloud management portal or product that is more of a policy-based standardized type of engine that's really evolved from more taking workloads and saying that, hey, I need to scale this out to X amount of nodes to something that actually makes predictive policy-based decisions based on what the customer's specific requirements are. So as an example, if they have a HIPAA compliant workload and they need SED-based backend storage on that, there would be an API that would communicate down into whatever that storage platform is, and it'd be able to encrypt RAID arrays, it'd be able to encrypt down to the drive level, which obviously protects it from physical theft. Other things like retention policy planning. So if you have a bucket policy or something like that that shoves things from Amazon S3 into Glacier, as an example, or goes to on-prem into an object-based model, the CMP would actually be able to standardize that. But what's great about a lot of the CMP technologies now is it's actually looking at it from a complete ecosystem perspective. Instead of one siloed product, this policy can apply through different APIs and make a unified decision across public cloud or private cloud simultaneously to ensure that the policy footprint for that organization is being met. And above everything else, it consolidates that all into more of a single pane of glass type of environment. So when people actually do end up making these decisions and they need to make it rapidly, they can do that through a single pane of glass rather than multiple different tool sets that may require different skill sets to manage and operate. And a lot of times these decisions can be part of a workflow. So when something's kicked off, it automatically encrypts something, or it automatically kick off a UTM or a VPN or something like that. So there's a lot of different ways that this can kind of come together, but I see the current ecosystem kind of starting to go in this direction where CMPs are becoming more policy-based type of product instead of just strict orchestration tool sets. And by the way, if anybody has any questions as I move through this, please speak up, and I'll be more than happy to answer. So building the security infrastructure from the ground up, a lot of these are kind of a given. A lot of people immediately, when they hear security, they think encryption. So that's obviously going to be a major part. Ensuring that encrypted data, both in transit and rest, is done. That crosses all the different boundaries. So as an example, you may have an EMC array or something like that that has encrypted SED drive architecture on the back end, encrypted stores. But when somebody actually takes a workload, they want to ensure that AES 256 encryption footprint that exists on that storage platform also exists in, say, a bucket or something like that. So again, this is where a lot of this CMP utility would come in, is it would ensure that a policy is being met. If a workload is transferred off of a siloed storage, it would go and say into a bucket that's AES 256 encrypted to meet that basic guideline. Ensure there are procedures for wiping disks and memory and storage. A lot of people just think wiping disks, but part of the policy is that memory needs to be securely sanitized as well. Incident response, ensure there are specific procedures and roles between you and your CSP. So this is kind of another issue, especially when you start thinking network service chains and things like that. When there is incident responses, sometimes it's very hard to get the ISP to do something in conjunction with alert that was kicked off within your private infrastructure or your public cloud infrastructure. So again, this kind of comes back to the CMP or kind of more of a rapid alerting type model where it kicks off an alert to two specific areas, and then there's an SLA agreement that's in place or an alternate agreements in place between the ISP and the public or private cloud entity that would be able to instantly, rapidly respond to something. Or it could be something that's purely API-based, whether it's IDS, IPS. It could be something that kicks off an API call to actually turn something off. There's a lot of different ways of tackling this, but we're kind of seeing where the manual steps are starting to effectively evaporate, and we're starting to see this more as kind of an API-based orchestration model to accomplish specific security guidelines. Predictive tools, another big one. This one's always, and I'm sorry, that's actually misspelled, but IDS, IPS, that one's rapidly evolving. Threats are always rapidly evolving, so you're going to see that constantly change. SDP, which is a secure data protection type model, that's another one that's moving pretty quick. Auditing, API monitoring, advanced EDS mitigation, and internal threat monitoring, and being able to, like I said, couple that into a kind of a single system. And then continuous monitoring, which is becoming one of the more important ones with a lot of the newer security tool sets. It has to be alert, it has to be alive, it has to be a 24/7 type of environment that can be easily, rapidly responded to and be able to close threats. And some of the questions you would ask is how the CSP provides reports and security events and responses, and how well do these alert systems actually couple with your internal infrastructure and your current monitoring infrastructure it's set up. Is it something that still requires a lot of manual steps, or is it something that can actually be unified through either like a CMP or a specific type of monitoring tool set that makes API calls? Are there professional services in place to immediately assist? So a lot of people will look at that as software-specific type of changes that need to take place to be able to mitigate a threat or block a threat. But a lot of times within the professional services infrastructure, there's also that physical aspect to it as well. So I can go back to SED drives as a good example, is some of these things are actually done at the firmware level, down the hardware. And you're starting to see things push down further into that hardware set now, that you're starting to see things like Mesosphere and other tools that would actually leverage the bare metal infrastructure, make API calls down to that as well to be able to mitigate risk. The other one is identity management. And most of you have already seen that, Amazon and a lot of others already have multi-factor authentication. Google does it with Google Authenticator, YubiKey. All of those things are obviously very important, and most of the specific PCI kind of DSS policies and things like that are starting to require a lot of multi-factor type of models, which is always a relatively good idea to have that in place to be able to ensure the maximum level of security for logins. And then, of course, the most obvious one is know exactly who is coming in, who is accessing your physical data. Are the physical devices that store the data secure? And I'll use SED drives as a great example again. So if somebody takes a drive, and they remove it physically, it's not just an encrypted file system on the back end, but it's actually an encrypted disk, which actually protects the physical device itself and the data on it from theft. And then we can look at network connections. A lot of people will leverage standard internet connections, broadband connectivity for cost. They'll do their own IPsec VPNs and things like that over it. But a lot of people are still very much liking the MPLS type of infrastructure where it inherently has a better security than a lot of the internet-based infrastructure, of course. But a lot of people even re-encapsulate their own IPsec VPNs inside of that. So it just depends on the security, overall security posture and what they want. And then things like, I can use Telari as a good example, where they actually do a secure broadband bonding type of architecture where you can actually span VPNs over multiple connections. And then also defining your multi-cloud strategy. What is your layer 2, your layer 3 connectivity model? This becomes a little more complicated as we look at different systems like OpenStack, and we start to go into some of the public cloud infrastructure that might be a little more basic. So as an example with Amazon, you have pretty good visibility into your VPCs and things like that, and your security groups. But that doesn't necessarily mean that you have very specific controls around a lot of your layer 3 connectivity. So what a lot of people are doing is they're using unified threat management appliances, and then they're pointing routes and they're actually managing their traffic within these. So those are good options for a lot of people where they may want a UTM, and that would give them a unified approach in not only controlling their traffic patterns, but also controlling the way that traffic flows between the VPCs and what type of threat management. So it can do a lot of layer 7 inspection where it's actually getting in there and looking at things like IPS, IDS, origin of packets and things like that. And how will you ensure the seamless connectivity between clouds? So this is kind of where SDN is coming in, where you have more of an emerging software-defined network type of environment. So rather than racking and stacking stuff and actually going through the manual provisioning models, you're actually in a place where you can provision a software-defined network infrastructure, and you can go in there and you can actually set a lot of these security policies within that and be able to orchestrate those very rapidly. Whereas before you'd have to do a lot of kind of manual intervention on that. So it's really speeding the process up. The issue behind that model is that it's still kind of rapidly evolving. There's still a lot of product being kind of shoved in that space right now. So it's not really, there's some products that are mature, but there are some products that are still kind of struggling with maturity there. So as we see SDN start to grow and continue to grow, we're going to start to see better control over the traffic patterns throughout the entire cloud ecosystem. And which cloud management tools would you use to manage your resources is a great question. There's a lot of tools out there. There's a lot of individual orchestration tool sets. Some folks may use Puppet Chef or Ansible or something like that for a lot of workloads. But again, these are tool sets that are now kind of being shoved up into a lot of the CMP products. And those CMPs would effectively use the Pythons and the Chefs and things like that, and then be able to orchestrate workloads within the CMP. And you'd even be able to move your own scripts and your own orchestration mechanisms within that tool set. How will you move your data back and forth in a cost-effective manner, in an efficient manner? That's really a huge challenge. Is the visibility into how that data is flowing between the different points is going to be a huge issue, and being able to track that. So a lot of folks, they'll do kind of a combination of billing or CloudWatch. There's a lot of different technologies in there to do that. But as the cloud, especially the public cloud ecosystem, becomes more cost competitive, people are really looking again more to policies where they want to know what the cheapest instances of the day for a dev workload. Or they might want to know exactly what the most compliant specific cloud product is they can place an instance on at any given time. So those are kind of metrics people are looking at to be able to make determinations on how cost effective their infrastructure is going to be for their workloads. And then how it'll affect performance, availability, and security. Obviously with the performance piece, whenever additional layers of abstraction are added in, outside of the bare metal components, that always adds a different level of complexity and it can slow things down. So a lot of people are definitely looking for ways to manage that virtual infrastructure, add additional pieces of that virtual infrastructure in there without seeing major performance degradation. So a couple best practices. Simplifying your infrastructure is going to be a really big one. It's kind of interesting because previously, a couple years back, we were seeing a lot of unified fabric, where there'd be a lot of vendor-specific orchestration APIs that would orchestrate a lot of these workloads. That's kind of pushed back now more into the software tool sets that are doing it, and it's looking more at commoditized type of bare metal. So we're seeing a lot of things like standard Dell, Supermicro type white box infrastructure that's actually being leveraged through these tool sets. And again, I go back to kind of Mesos and the entire like Kubernetes and things like that, where it's actually using low-cost, commoditized type of infrastructure that consists of standardized processors, standardized footprint of disks that doesn't have a large backplane on it, that's orchestrated through a single pane of glass that's provided by that specific vendor, which obviously makes it a little harder to manage for a lot of people when they try to break out and they try to actually bring that infrastructure into a true hybrid footprint. They're finding that commoditized stuff gives them better flexibility because they're not bound to a specific interface or architecture to be able to do that. And with that, because you are involved in that entire code base all the way through, kind of what the products are you're doing, and you have a better idea of the visibility and security of what that device is doing. And then we're also looking at, of course, the intimate knowledge of each component. Just talked about that, but that's a huge one, is knowing exactly what's being done within these environments and what's managing your hardware and what tool sets are being used to do that. And again, this goes back more to the CMP, but it's going back to software-driven orchestration, and it's actually decoupling the hardware-specific management mechanisms, allowing customers to take full control of their infrastructure. And I use a couple examples down there, obviously RESTful APIs. OpenFlow is a great one for folks that maybe use Arista switches, things like that. There's SFlow. There's ways to actually tell that hardware specifically how to orchestrate workloads in conjunction with a VPC or something like that. You can program that in. iPXE, which is down kind of the hardware level that allows you to bring servers up from a bare metal infrastructure. And then things like SuperDoctor is a great example of where the APIs are actually being leveraged to allow you not only to turn a server on and off, but also do on-the-fly things. If you want to do, like an instantaneous expansion of a RAID or something like that. And all these tools give customers greater provisioning, automation, control over their cloud deployments at the end of the day. And the other piece, of course, is cost that wasn't in there. Commoditized infrastructure, when done right, can be extremely cost effective, and it can actually save a lot of money. So the other best practices, of course, making sure you choose the right partner. Working with the right partner could be the difference between success and failure, and understanding how all those components come together and how they're going to couple into your infrastructure. And also understanding your business and specific industry needs. So as a great example, there may be very specific public cloud providers that are HIPAA compliant cloud providers. That'd be a great example of kind of aligning that public cloud entity with your specific business need if you're like a healthcare organization to ensure compliance is met all the way through the service chain. Otherwise, going with one that doesn't necessarily have that, it's kind of up to you. You have to go in and make sure you have secure bucket policies, you've got encryption across your VPCs, you've got secure control plane, and things like that. And then one of the most important ones, of course, set and monitor SLAs, ensure operational requirements are met and adhered to all times, and that tool sets are in place to ensure constant monitoring to ensure 100% compliance. Any gaps in that, where even if it loses data for 5 minutes, could be the difference between a non-compliant infrastructure and one that fails. Confirm your expectations are in line with your CSP's capabilities and never make assumptions. That's really kind of up to the individual customer to really determine how deep the CSP's capabilities are to meet their specific need. So the impact of tomorrow's trends, we talked a little bit about it, but obviously containers is a big one, microservices and real-time big data. So when we look at the containerization model, which really allows you to assemble applications from components and eliminates problems that arise when shifting code from one platform to the other, resulting in faster, more efficient deployment and more effective type of maintenance. Obviously having that standardized kernel at the very bottom and being able to deploy those apps off that makes the provisioning model a lot easier. And it also makes some of the actual security compliance pieces a little bit easier too, and that you're like with a kernels example, you're not maintaining multiple different kernels, you have a standardized infrastructure underneath, and then you're really focusing on the core application to ensure that that application is meeting a very strict compliance, rather than looking at it on a per operating system basis and an OS running inside of each individual virtualization instance. It really subtracts from that. And then easier, faster provisioning, improved version control, and then fewer underlying components. Now, that's the big one with performance, is that with containers, especially because you are removing a lot of these additional layers of abstraction, so we can use a VirtIO driver as an example. You'd be removing a lot of this and decoupling that, where you're actually pushing more back into a bare metal type of performance footprint rather than one that has all these additional layers of abstraction that are starting to slow things down. And that's not universal across the board, but it does seem there's a lot of gains around bare metal specific performance improvements on the infrastructure. Then microservices, software architecture style in which complex applications are composed of small independent processes and language agnostic APIs. A lot of folks, when they are developing now, they want that agnostic type of deployment model, so that's very important. And then determining better autonomy in terms of DevOps, faster product release set cycles, and continuous delivery is reproducible. Huge one, and that if you are deploying secure applications, compliant applications, you want to be able to reproduce that as much as possible without the pain of having to go through individual operating system deployments and things like that. And then the last one, real-time big data. Impact along with your volume, you're also getting velocity and variety. And real-time processing allows near-instant alerts within hybrid cloud infrastructure. So that ingestion of all that data and having the big data infrastructure in to be able to ingest all the monitoring, all these other alerts and things like that and standardize it into a single pane of glass is going to be very, very important. So what we see here with some lessons learned. Guilt is a good example. It's an innovative online shopping destination that offers customers special access to most inspiring merchandise experiences at all insider prices. They were challenged with delivering consistent uptime, fast speeds of 24/7 in a very global type of audience. And with significant experience in providing hosting, managed service, and hybrid compute infrastructure, Carpathia is able to get in there and actually help them manage the highly sensitive workloads they had and a lot of the latencies that they had, specific requirements they had for their workloads and ensure that it was meeting those massive scale guidelines. And to support Guilt's millions of customers around the globe, Carpathia provides the online retailer with a fully managed hybrid IT solution, which usually encompasses reaching out to different public cloud providers to be able to provide a true hybrid footprint for large customers. Kobo, Toronto-based. Kobo has quickly become a global leader in e-reading. So as Kobo sees large increase in the use of its network around holidays, they're going to need sudden high demand availability workloads and bursting. Because Carpathia really is global, and they have a global footprint, And now with QTS, we have a more expanded type of data center footprint. We are able to introduce hardware vendors to really help with a lot of their regulatory requirements and their challenges and meet very specific guidelines they had around compliance specifically. And through Carpathia, Kobo blends dedicated infrastructure with cloud services, allowing web traffic to be distributed across dedicated cloud servers. And again, we kind of structure, when we look at these workloads, we structure it around, like we were talking about before, cost, commoditized type solutions, and then looking specifically at those environments and addressing how we can actually meet very specific cost demands through a hybrid ecosystem. A lot of these customers are very open source type specific. Some may be more commercialized. They want specific vendor. So we really try to kind of blend both of those, figure out what cost points we can address, and then develop the proper solution to meet those requirements. Sorry about that. Do a little Java. Okay, so QTS and Carpathia, pretty straightforward example. As I mentioned before, dedicated solutions we focus on, and we traditionally have a lot of experience within the managed colo space. That includes private cloud solutions, dedicated bare metal servers, low latency workloads and things like that, and low latency network infrastructure. And then actually being able to blend the cloud management piece across to the public cloud domains and be able to stretch those workloads into AWS through things like Direct Connect. So if customers do have a specific bursting requirement or something like that, we can set up a higher speed Direct Connect link or something like that to be able to address that and allow them to burst those workloads. So our methodology really is understand how the infrastructure supports or drives the company goals, and develop a preliminary recommendation addressing specific architectural needs that revolve around things like high security and compliance, and engage in ongoing discussions to revise the design until it meets all desired parameters, and that includes performance, availability, cost, simplified management, hybrid connectivity, things like that. And that's it. Did anybody have any questions on this model?